So I think we finished the introduction.
Yep.
All right, excellent. We're going to move on. Put the slide down for you. So next up, we're going to do a review of Rstudio, as well as descriptive statistics. So we're going to just do descriptive statistics first, then we'll do one variable test, two variable test reviews, so kind of building up to where I think we need to be in order to start learning the new material. All right, so R in Rstudio. So R is the stats program that we're going to use. It's open source, it's free. Get it from rproject.org. All right, can I give you a heads up? I'm currently using one of the newer versions, version 4. I think it's subversion. And when I checked, my desktop computer here is 4.0.3. All right, so if there's a new release, I'm updating that. So you can make sure you download and get that. Now, this is more than just a stats program. All right, it does molecular analysis. You can import your sequence files and do molecular trees, do Bayesian analysis. You can do mathematical analysis and computation. Math and physics uses R. That's some of our math majors, like bio minor students, that they come in here being familiar with R. You can also use it to produce publication quality graphics. Surprise, surprise. They actually look good. It takes some time to learn, but you can do it. You can do it. And that's, I don't know, a lot of my recent ones are all in R. Now that's the stats program. What we're going to do is use Rstudio as the front end for it. All right. So the front end is just basically going to open up its own instance of R. All right. And then anything we do in Rstudio is just going to pipe it to R, and then R is going to return its results back to us. All right. So technically, Rstudio is a development program. IDE program. All right, you can get it at rstudio.com. I'm currently using 1.3.1073. All right, it's free to download. All right, we're not a commercial entity. We're using the free version of it. Now, again, note all of the stats are actually done in R. So when you cite it in your papers, you're citing R, not Rstudio. All right. So why do we use Rstudio? Why don't we just use R? It's several things. One, it's easier to import and load external data sets. Right? It's import dataset function. Opens up windows. We select. We navigate to the folders, find our file, open it that way. Right? If you didn't do that, you actually have to type in the code. So just demonstrate. Let's see here. Where are the rest? This is R. And it's just command line. That's all it is. If we wanted to read in a file, we would actually have to know exactly where it is located. And not just that, I'm going to open up a script that I have to make it a whole lot easier. I think we can three-way ANOVA. Here's our location. Actually, I set the working directory. That's the full location. You would probably know, oh, it's my home folder. Go to home folder, go to documents, right? But here I'm saving it on the network drive. How do I get to my network drive? It's not a P drive, it's file serve 2. It's connecting to a network drive. I had to know that. So you can see that it's actually quite difficult if you're not familiar with working with file folder structures. to actually import external data sets. It can be done once you learn how to do it. A lot of times it's you set this one working directory, copy and paste it into all your scripts, and then you can reference everything as normal. But Rstudio makes it a whole lot easier because it recognizes the folder structure itself. The little tilde sign, your squiggly sign, references the home directory, so we can just use that to reference our home directory, and everything else falls into place, and we'll see that. All right? Installing and loading packages, real easy. It's just go to the packages, install, or you go to the package list and you do the checkbox. I'd say loading packages is actually pretty easy in R. It's a simple code. It's just library. All right, that loads the package real easy. But how do we install it? Well, we have to go to install packages and pick our mirror, and then it opens up the window, and then we just go ahead and select our packages that we want. And of course, we can do searches if we really wanted to. There's ways to do that, but it's just a little bit more tedious to do it in R. That up. Convenient environment to write code, view output, and read help files. You'll see it. If you haven't worked in it, we've got different windows. We can have a help file open as we're actually writing the code. We can have a figure open as we actually write a code, and so forth. Writing our own packages. If you desire, you can write it. This is a developmental program. This is our front end. We can grab and pull multiple scripts, multiple files, and say, hey, I want this package to have all of this stuff. I've done that. Later on, if you choose to do something like this, yeah, Rstudio works great. And lastly, it allows us to create formatted reports. This is something that we're using in terms of the Markdown package. Nice thing about this is that we can write text and then have these chunks that represent the code, the executable. And if you were putting together, let's say, a PDF or writing paper, you can insert these chunks and have it automatically inserted into the final draft of your paper. Are you going to do that for your thesis? Probably not. You're probably just going to write it in Word and then paste the figures into the file, because that's what we're familiar with. But somebody who's familiar with, let's say, the LaTeX engine, creating PDFs and stuff, this is very easy to export right to their LaTeX engine to produce their publication quality papers. All right, so with that, we are going to be using these Markdown packages, the Markdown documents. Hopefully on all of these computers, it should work, hopefully. Let's find some wood on this, all right? So this Markdown document is going to create a notebook, all right? We're going to write our text, take our notes, answer questions, and then we have these code chunks. And then when it's time, we're going to go ahead and knit the document that basically takes the narrative text and the code and the output and puts it all into a single document, either a PDF, Word document, or even maybe an HTML document. We're going to use Word because I'll give you a template where all of the different styles are set up. The font sizing, font type, the text flow, so your indents and your spacing before or after paragraphs, it's all set up for you. So what R will do is start to create this Word document and then apply it into the template and save it as a new document. So how do we get to the R Markdown document? File, new file, R Markdown. So let's go ahead and open one of those up so you can see it. And I do suggest keeping our Markdown document to take notes. So this is. All right, so just right up here, I go to File, New File, and then R Markdown. And if it works, it automatically opens up this new window. If it doesn't, it might say, hey, we need to install or update packages. Hit yes, let it do it. And then when it's done, it should open up this window. If it doesn't, let me know. Let's go ahead and make a Markdown document. And actually get to this window. And I think for here, I'm just going to call it 2.1 Descriptive Stats. And at this point, You can do Word, PDF, or HTML. I'll do Word just so we can demonstrate doing the knitting function. Is everyone happy? If you're on your own laptop, you might not have it accessible. You will actually have to install the Markdown package. And the Markdown package will then bring in a bunch of other packages. Call this, hit OK. It actually makes this Markdown. Right, so this kind of gives you a rundown of how things work. All right, so as we get to the Markdown package or document, let's just kind of orient ourselves in the RStudio window. I know I covered this in our undergrad class. This is our script. This is basically a notepad document. That's what it is. Notepad or WordPad document. Just basic text editor. All right. The Markdown adds some color to it. And actually the new version of RStudio, I haven't updated. I think the new version of RStudio came out last week. But it's supposed to add additional colorization to the text. So kind of separate your headers. Like this already does a good job. So sets the headers as blue, sets the regular text as black. They're supposed to do some other stuff and recognize different types of code. But this is basically our text window. Here we have our global environment window. All right, as we import data sets, you're going to see the data set appear here. When we create a function, it's going to work there. So if I run this standard error function, it appears in our environment. Now, I don't save my environment every session. I close it out. I don't save it, so that way when I start fresh, my environment is completely empty. All right, I like that. That's what I prefer. I recommend doing that because you don't want to have a bunch of stuff in the environment, open something up, run a command, and it works. You're like, hey, great, that works. I get this response, and it's like, hey, Dr. Dollar, it's like, great news. I got brand new result that says the home range of this skunk is twice the size previously known. It's like, that's awesome. All right, and then 2 days later, you're working on a different computer, you do it, and it's like, what the hell, I'm not getting the same response. Well, it's possible that you didn't import the data set. You used the variable name of that data set in another script. So when you did the analysis, that variable doesn't actually refer to what you were expecting. And it was because it was left over in this environment. So that's, if you start and there is stuff here, it's very easy just to click the broom to clear it out and start fresh. Anytime you start running into problems where it's like, yeah, this used to work, sometimes it's good just to kind of clear it out and say, let's only load in what I know I need and see if it works at that time. Down here, this is our console. This is the equivalent of this. So again, I said RStudio creates its own instance of R. This is it. This is my instance of R here. If I create a new script, this is just a basic text editor, Notepad or WordPad. That is the same as this upper left panel in our Markdown or in RStudio. So you can see, the similarities between the two. Now, regular version of R doesn't have the environment window. This is an addition. It also doesn't have lists. So this window, it could be our help file. It could list all of the packages that we currently have installed. All right, and you can see the ones that have a check mark are already loaded into memory. They're accessible. Our plots could appear here. All right, and the plot keeps a history. I think the default is 20 plots. So if you're making plots and you say, oh, I wonder what that plot was, 5 plots ago, you can cycle between it with these arrows. Also has the file browser. I don't know, I don't normally use that. Normally it's between the help and the plots. They also added this viewer. I think this viewer is for like HTML. You can see it render. Don't hold me to that, but I think it's related to rendering some of the code you'll see what it actually looks like in the output. What about the environment window? Well, the environment also has a history. So you can see this is everything that I ran. This is, I think, all left over from last semester. And it keeps a pretty extensive history. All right. I can load 212 more entries. Yeah. Looks like I'm doing some subsets of pairwise comparisons. All right, and then the connections, again, we don't use this here, but if we were connecting to a remote database, so in, let's say, a company setting, you have one central server where everyone uploads their database to, that's in, say, SQL or some other type of database format, we can connect directly to that database from Rstudio and from R if we wanted to. Okay. So that's the rundown of our Markdown. When we create that's a rundown of Rstudio. When we create our Markdown document, it looks something like this. And I know there's a way to actually create it fresh. It doesn't have all this stuff, but I haven't bothered. So this is just kind of the introduction. It runs you through. You've got headers marked by pound signs, right? So 1 pound sign, 2 pound sign, 3 pound signs, 4s. Those code to the header 1, header 2, header 3, header 4 in our Word template. All right, so you can specify your templating there. This area is a chunk, and this is an R chunk. How do I know that? It's because it said it's R. All right, and this is the code block. So I can run that code by hitting the arrow, and it puts the output right there. We can do the same thing in the console. I will run it, and it puts it right there. All right, and what this is actually doing is kind of embedding miniature versions of the R console in our text. Kind of the way you can think about it. In reality, it takes the code, copies it, pastes it, and runs it in the console, copies the output, pastes it right below here. Long way of doing it. All right, and we can do plots. So make a plot, it shows here. Now, I don't normally do this. I take everything out, and I start fresh. And there's one chunk that remains. So this top part is very important. The very top is our header. All right, it's marked by these 3 lines up top, 3 lines at the bottom. These are actually the dash key. So on this is the key next to the plus equal sign. All right, it's not the underscore, it's just your dash. So that sets our header, and it tells it tells the package that knits the document how to handle everything. So it gives it a title, right? We give it an author, we have the date, and then the output. Now the output is set up as a Word document. We're going to be changing that. We're going to add a template to it. If it was the PDF, it would be a PDF document. It tells the engine, hey, take this, we're going to weave it together, we're going to knit it together, and then we're going to output it as, in this case, a Word document. After the header, then we have the options, the setup chunk. This kind of lays out how we want the Markdown document to behave. Here we leave it alone. So what it's saying is that when it runs this knit function, when it takes our document to create the word, all right, as it runs the chunks, we're going to say echo equals true. So it's going to repeat the code, it's going to repeat the code along with the output. And that's what we want. That's what we want. We also have a setting where we can suppress the output. We can suppress that warning and the error messages. But we're just going to leave this as is and not worry about anything else. And then after this is where we can start. All right, we can do our basic heading and then any text, any notes that we want. And we'll add to that. All right, so we created a new Markdown document, and I consider that a great way to take notes for this class. You can follow along, you can type in your code, and then when we have these situations where I say, now you try it, do this analysis, you do it, and we'll check it based on how I do it. So ideally, you have a copy of what I've created in class. All right, so our output looks something like this. You can note that for the reference for the Word document, we actually add additional line to it. It's called reference docx, all right, and we name it word template.docx. That word template is a template that I posted. You're going to save it, and it's going to be in the same folder where you save that RMD file. All right, and it has to be that exact name. All right, it has to be that exact name, and I guarantee that people will have a problem. Won't it? Because you downloaded it, and you downloaded it a second time, and stupid Windows will automatically add a 1 in parentheses after that, and you won't know. Guaranteed. We'll also have someone that knits and they don't have the file actually in the folder. Guaranteed. It'll happen. We'll get it. So what I'm going to do is go ahead and add that reference line. So when I hit enter, the spacing is definitely important. So I have output, new line, 1, 2, 3 on the third character. That's where we start with our Word document, enter, and then when we press enter, it'll put us underneath the R to start reference doc. So mine could look something like this. What's that?
How did you do that?
How did I do what?
Make it all spaced out like that.
Yeah, when I hit enter, I just use space bar. I don't think tab will work. I don't know. I don't think it used to work. They may have fixed it. That may have been an upgrade. That he did it? All right. Exactly. Tab key is its own key.
Oh, so like it reads it as a tab key and has a space?
Yeah.
Let me go back to space.
All right, so we get that set up. Reference. And we'll check, we'll make sure it knits properly. Once it works, then you're going to see we can just copy this, the entire line and paste it in any new our Markdown document that we have. Any of the RMD files that I post will automatically have this in here. All right, so we already went over number headings, right? The hashtags. Yep, talked about that. We talked about the chunks, and we'll clarify the chunks a bit. So the chunks, as I said, we're going to do with R. If we wanted to add a chunk, how do we do that? So just introduction, we do something, and now we want to add a chunk. We can use the insert, and then we have our options. And this is nice. We want to add an R chunk. Insert a new R chunk. And when I hit enter, it adds it. And now it's ready to go. What if we wanted to run some Python code? Insert Python. And you see what's changed is just what's in here, what's in the braces. This chunk is actually, it's a shortcut to do it. It uses the accent mark. 3 accent marks. All right, and then in the curly braces, we have to specify what the code is in that chunk. So that's R. And then you'll see when I hit enter, every time I hit enter, the chunk is just going to keep getting bigger and bigger and bigger. We close that chunk by using the 3 accent marks again. So if you wanted to do it by hand, that's how you do it. I typically don't do that. I typically don't even use this insert. Instead, there is a keyboard shortcut, Control-Alt-I. Blake, yours is probably Command-Alt-I.
Command-Option-I.
Really?
Yeah, on the Mac.
Jeez, oh man. You guys, you Macs. It's
the worst.
Backwards. No page up or page down keys. Jeez, man.
Can you close the chunk with Control Alt I also?
What's that?
Can you close the chunk with Control Alt I also?
I don't think so. No, no. So Control Alt I actually inserts the chunk. So when Rstudio, like before version 1, it actually gave what the shortcut was up here. So it was real easy, and you can make shortcuts, but the default shortcut is Control Alt I. Just like when we're in a chunk, summary cars, like that was in there. If I just hit Enter, it just creates a new line. So how do I run the chunk? Well, I can run the chunk by hitting the play button. Right, that runs it. Or, that's what I do, Control Enter runs it as a shortcut. You're sitting on here typing, you don't want to go back to your mouse. So you tend to learn these shortcuts. So we add our chunks. All right, so remember here, all commands, including loading libraries, functions, and datasets, must appear in a Markdown file. Those of you that are new to this, what am I talking about? It's this. I'm going to import a dataset, just a generic dataset that we used last year. All right, I should say in the fall. I think we did butter. Oops, hold on. Butterfat was getting still back. Execution. I don't think this will happen on yours. I know it happens on mine. Sorry, that was my mistake. The shortcut, the docs, doesn't work. It doesn't parse the correct location. So let's go down to turkeys, do this around Thanksgiving. Import my data set, and we'll show how to import it. But imports a data set, and I write all the code. I've got all these chunks, right? And then I save the RMD file, and then I open it up later. It's like, and I run it, and it's like, error, I can't find this variable. I can't find this data set. Well, it's because we went through this import data set. So anytime we import the data set, what we do is we go down to the console window. That is the code that was executed to read in that data set. So I'm going to take that code, copy it, and then paste it in a chunk right at the top. So now when I save our Markdown document and I open it up at a future date, I don't have to go through this process of importing the data set. I can just go ahead and say, run this chunk. I've got my turkeys data set. Example. This is also from the fall. This one. I don't even know if that was part of what violated. We'll do ANOVA. Here's ANOVA. This is from the fall. I have my data set. One thing that I can do, this is all saved, is I want to get to this. Let's run the t-test. If I just run that t-test, if I run this chunk, I'm going to get an error. What was it? I lost it. Did it go today? There it is. Yep. Error, right? Not found. But I didn't read in the data set. Let's say I start as a grad student, I close down for the night, come back the next day. I want to get back to this point. In the chunk, I can run all chunks above. And since I had my code that got back to, since I had the code that got me the data set, imported the data set, everything's going to run. Now, here's the problem with this, is that we have had a change in file format, and the strings as factors is very important. For some reason, it is no longer a default. So, that was my error message. It stopped right at the plot here because it needed a finite xlin, which means that this fertilizer isn't being read in as a factor. We fix that, run all the way up to there. Now, where is our raspberry? Raspberry plotted. Now when I run it, it works. So, very useful. Copy and paste your code, especially your functions in your import data set, which is right at the top. It's already there. Saves you loads of time. All right. So, now that we have our introduction of R and RStudio, let's get to using it. We're going to quickly review one continuous variables. All right, and we're going to use R for that. So, just kind of setting this up. Things what we're going to talk about are measurements of location, means, medians, and so forth. We're going to talk about measures of dispersion, so variability, so variance, standard deviation, standard errors, and so forth. All right, we're going to talk about reporting, means and standard errors. We're going to and we're going to actually show how to calculate it in R. So what we're going to do is kind of set up our R Markdown document to get things going. So we're going to have a data sets. I believe we're going to load a data set to do some of these calculations on. I also know that we're going to be using some functions. All right, so we're going to need a chunk for the functions. So load data sets for this file. Load the functions for this file. All right, and as we get to the data set, as we get to the functions, we will then go ahead and get them into our document and run them. All right. So, what are our calculations? These are our equations. Hopefully they kind of look familiar. Hopefully they kind of look familiar. We got the mean, sum of all of our x's divided by our sample sizes. We've got our standard deviation, which is the square root of sum of squares divided by its degrees of freedom. So x minus x bar squared, that's sum of squares, sum of our squared deviates, right? The n minus 1, that's our sample size minus 1, degrees of freedom. Standard error is going to be the square root of our variance over the sample size, or standard deviation over the square root of our sample size. Should have already had this in a previous stats class. Right? So what we're going to do is kind of go through and just calculate all these important ones using the water data set, water.csv. This is posted on Blackboard. Hopefully, those of you that had the stats class remember how to do this. Right? Cody, have you lecture on it? No? There's our Blackboard site. Under lecture, we've got descriptive statistics. I've got the water.csv and the glyco.csv. All right. If I just click on water, it's going to download, which is fine. Right? But it doesn't always work. Sometimes when you click on it, it'll actually open up a new tab and show the actual comma delimited file. So if it doesn't download for you, what you want to do is right click on it and you want to save the link as. And then you want to put it in some place where you know you're going to find it. recommendation has always been to save it in some sort of standard folder. All right, and how I've set it up on my network drive here is that I have a folder for the class, biostats class. I have a folder for all of my R stuff. All right, and in that R stuff, I have different folders. One folder being the data folder. So then what I could do is save all of these data files right to my data folder. All right. And you can see it. It's already here. I've already downloaded it. So when I try to save it again, Windows is going to add a 1 to it, which I guess they're being helpful because you don't want people overriding, let's say, their tax returns, you know, with next year's tax returns, and then they get audited and say, oh yeah, I've got them, and you open it up and say, why do I have this year's tax return on there? So I understand why they do that. It's just somewhat of a hassle. I'd rather be prompted to say, hey, do you want to overwrite this file? And then it's like, oh, maybe I better change the name. So make sure it's called water. And here on this computer, I can't see the extension, but it is water. It's a Microsoft Excel comma separated values file. I've already downloaded it. Also, go ahead and download the Glyco file. So once it's downloaded, then what we're going to do is import it. All right. You're going to read this into R, and then you're going when you read it in, you're going to read it in as the file water, or with the name water. All right. So go ahead and do that. As you're doing that, here's the rundown. Let's say we collected 100 water samples from various aquatic systems across Texas, and then recorded some important water quality measures. We measured feet from shore for where we collected the water. So, you know, some cases we may have picked it up like right, you know, within a foot of shore. Other times we may have like gone out to our ankles to get that water. We also recorded the temperature at the site of collection. So when we went out to collect, we dropped the thermometer and recorded that temperature. In that water sample, we measured the algal biomass by counting the number of cells per milliliter. A couple different ways to do that to determine productivity of a system. And then we measured dissolved oxygen, DO. So that's lowercase d, capital O, and not 0. All right. So I imported the data set. Into R, just following this process. All right, import dataset. We're going to import it from text base. That's also kind of important because we have a couple different libraries that Rstudio will use to import the dataset. We want to make sure we use the base so that things work correctly. All right, the other one is dataset. So if we did reader, it'll actually import the data file as a different format, as a different object, which I'm sure people get comfortable and become really good at using it, but it's not, I don't think that's universal. This reader package is probably really good for data scientists, data analysts, which that doesn't really include us. All right, we want it to be, when we read it in, we actually want it to be read in as a database. So from text base, I go to the location where I've saved it, my network drive, biostats, R, data, water, open, and it opens up our preview window. In our preview window, I'm going to change the name, make sure my name says water, which the default is just to take the file name, which works sometimes until you start saving a file name of water, summer 2021 underscore Northwest Texas underscore trial number 5.555 or something like that. It's a really, really long name. You don't want to keep typing that over and over again. All right, call it something simple, short. Make it easy on yourself. What's the rest of this stuff? You probably don't need to ever adjust the encoding. Possibly if you get a data file from, let's say, a colleague overseas, you may need to do that, but I don't know, I haven't seen it. Heading, typically yes. So this is there a heading row? You can see in the file, I do. I have a heading row that specifies what each column is. That's going to be our variable names. The row names, automatic. If it recognizes the row names, it'll say that they are there. I never save anything with row names. The separator is comma. It's going to recognize that. It should automatically recognize what our separator is between columns. If it doesn't, if for some reason it thinks there's spaces, you're going to know you have a problem because the quotations at the top will likely be one here and one at the end saying we basically have one single column. So now's the time I can see, yeah, we've got 4 things listed, and if R parses it according to these settings, this is how it's going to parse it. 4 different columns, feet, attempt, algae, and deal, and that looks good. NA strings, if you type in your data into Excel, if you have missing data, you leave that cell blank, or at least I do. I leave it blank. If you put like a period in there, you need to tell R that the NA string is a period in order for it to read it properly. And what R will do is basically convert that to an NA. But if you leave it blank, it's okay. The last thing is this, strings as factors. This was a new change in the new version of R Markdown, or Rstudio. For some reason, this is not automatic, and it poses some real problems. You already saw when I tried to do that graph, it said, oh, xlim, you need finite xlim or something like that. Well, it's because it didn't read in the strings as factors. It just read the strings as strings. And when it runs the code to say, hey, I'm looking for the different factor levels to plot, if it's listed as strings or comments, it's going to fail. So just all the time, make sure that's marked, that checkbox is marked, and then you hit import. So I don't like how Rstudio automatically opens up this tab. I'm sure there's an option to suppress it, but I close it. I know it's in there because it opened it up to show me the data. And also, it now appears in our environments window. Dataset, I have 100 observations of 4 variables. I can do my drop-down arrow, and it tells me 4 variables are feet, temp, algae, and DO. It tells me feet is an integer. It tells me temp is numeric. Algae is integer. DO is numeric. All right, so I know it's in there. It looks okay. So now what I'm going to do is take this code that was used to import our data set. I'm going to copy it. Control-C, or the Windows, non-Windows users, probably Command-C, right?
Yeah.
Then paste it up into the datasets file, datasets chunk. And that's mine. Yours is going to be a little bit different because it's a different location, file location. This is for this computer. On my work computer and my home computer, normally the location is a squiggly line to represent the home folder, and yours could be that way. So, like I use Dropbox to save a lot of the stuff. So I have the squiggly Dropbox, and then I have my Dropbox folders, set up so that they look identical on all these different computers. So no matter what computer I'm working on, the same location is on every single computer. That saved me time, big time. All right, so hopefully you have your data set read in, right? And it's important for that strings as factor. That's why I put it in yellow here, all right? Something new, make sure it's checked. If it's not, you'll get some error about, xlim not being finite. All right. All of the files that I create and send are going to be CSVs. There may be times where we have tab delimited files. Usually R is pretty good at distinguishing between the two. All right. They have a generic read table. The actual function is read.table. All right, where a read table then needs to know what that separator is for the different columns. R got around this by using this read.csv, read.dlim, a couple other things, where this automatically puts in the code into this read.table. So you can say read.table is a higher level function. We use the read.csv that then takes the information and parses it to read table, which then executes everything. So hopefully you've got it in. So just for practice, do glyco.csv. Call it glycogen. Make sure you copy and paste the code into that dataset chunk. And then be able to answer the question. What are the names of the variables that are found in this dataset? Then I have the this last question is, what function or functions would also give us the names? Yep. Where'd you find it? Is it on the next slide?
No, I did names. Yeah, not funny.
Works. Did you get it? Any errors? I don't think it's black.
Type names. Type names.
So we've got, yeah, I've got my data set. I copied and pasted it again. Important to do that. So that works out. Check the names of the variables so you can do the drop down. Right? Or we can use a function. So basic functions. Finding the names of the variables in data frame. Names. Names of a data frame. Names. That's the function. It'll tell us exactly what the variable names are in that data frame. Now, in this names, you can see, or in the environment, you can see that we have factors. Treat, rat, prep, read, glyco. Right? What if we wanted to know the levels of treat? Right? We know it's a factor with 3 levels. I could probably, no, I can't. So I can see it's coded in as 1, 2, 3. All right, but there's labels associated with it. How do we find the names, or how do we find the names of the levels within a categorical variable?
Summary.
Could. You can also do.
There are levels in that?
There is, Blake. Man, it seems like you've been working on R these last few weeks. All right. So, and yes, we're gonna do the summary too. So the levels function tells us the levels in a specific variable that's found in the data set. All right, so levels, we're looking for treat, and again, it's going to have to be the capitalization is important. We're dealing with, Unix subsystem, a Unix format where capitalization can change everything. Lowercase treat is different from uppercase treat. Now, if I do levels treat, I mean, that's what we're looking for, right? We're going to get an error. It's going to tell us object treat is not found because R doesn't know where to look. Treat isn't in memory. That doesn't appear in our global environment. Treat isn't there, but glycogen is. And that treat is actually found within the glycogen. So in order to access that variable, we're going to have to use the data frame $variable format. Glycogen. So now what we're saying is we want the levels within the treat variable. And that treat variable is found in our glycogen data set, or in the object glycogen. All right, and this could be useful. When we run codes and we save a model, the model itself is going to have different labels attached to it, different names, different levels. So we can kind of extract that information by using a $sign with it. You're going to see me do this in some of our scripts. All right, so now if we do this, now we get our levels. And again, note the capitalization. If we ever want to reference one of these levels, we have to use the capitalization exactly as it appears in our data set. No exceptions. This includes spaces. This includes spaces. So if you happen to be entering data into Excel and you get to a cell that is missing data, right? Typically, you would just hit enter and go to the next cell. Leave it alone. But in this case, you accidentally hit the space bar, and then you hit enter. That cell still looks blank, right? In Excel, still looks blank. But there's a space there, and there is an ASCII code, a key code, in the actual file. R sees that space as an actual character. And when you do levels, you will get compound 217, compound 217 sugar control, and then quotes with the space between it. What do? Go back to Excel, find that cell. So capitalization, spacing, very, very important. Now, we also had a summary function. Our function is summary, and we pass it, we give it an object. And the type of summary that we receive is dependent on the format of the object. So the output of summary depends on the type of object. So it could be data frame, vector, model, etc. Anything. There's going to be a different summary function for that object. So summary isn't really a high-level function. It's a low-level function. What it's going to do is take that summary, look at the object that we pass it and say, okay, well, what is the structure of this object? All right, and just kind of as a demonstration, we check structure str of our glycogen data set. And it tells me that it's a data frame. So the summary sees, oh, this is a data frame. It'll then pass it a summary function that's specific for the data frame. So when we run our summary then, summary on the glycogen data set, we get a summary of each of the variables in our data sets. So for us, yeah, we can see all 5 variable names. We can see the levels. We see compound 217 sugar control. All right? We see the count, how many there are of each level. So in this case, we've got 12 of each. So 12 rats were exposed to this compound. If we have a continuous variable or some sort of integer, all right, numeric variable here, it's going to give all of these summary statistics. The minimum value, the maximum value, the mean, the median, the first quartile, and the third quartile. Right? This isn't the preferred method to look at the levels because it's only going to give 6 levels. After that, any extra levels, it'll just group it under others. So if we have, what are the levels of prep? This doesn't work because we don't know what these other 24 levels are. We actually have to go through and do levels, glycogen, $prep to get that information. Those are basic functions. Any questions? All right, so what about summary statistics? R has been nice because they made the functions for their summary statistics, what I would say, idiot-proof. If you want the mean, the command is mean. If you want the median, the command is median. All right? So hopefully self-explanatory. Most things are like that in R. There are exceptions, the Levine test, but we can talk about that in a bit. All right, so these are the various individual functions. In all of these functions, these are just the generic format of the function. We have x. And in each of these, x is a vector. That's what we have to give it. All right, we have to give it a vector. And what's a vector? Basically a column of data. Right? We have to give it a column of data. And in most things for these, that vector is going to have, it has to be numeric. You can't calculate an average of shirt sizes. Just can't do that. You can get maybe counts of shirt sizes, but not averages. Could you do a median of shirt sizes? Maybe, if you convert it to ordinal. Maybe. But it needs to be a numeric vector. Right? So if this numeric vector is buried inside a data set, you're going to have to use this the data frame $variable name in order to get that variable. All right, so this data frame $variable is itself kind of like a function. It says, hey, I'm going to return this single vector, and then I'm going to pass that vector to the function that we want. Now, all of these have this na.rm equals t. What is that? What is that?
Removing the NAs from the data set?
Yeah, we're removing the NAs from the data set. Why do we need to do that? Because R won't process the data right. Yeah, we can't have missing data. And the default is that na.rm equals false. Because by default, you want to keep everything. And in some things, like when we do regression analysis, it works. The regression analysis function will actually automatically remove the missing data, but these functions will not. So if we ever have missing data, or you don't know you have missing data, and you run mean of your vector and you get NAs on it, try na.rm, see if that works. Right? So what I'm going to ask you to do is go ahead and calculate each of these for the temperature data in our water data set. Just to make sure it works.
I mean, either one of
Give me the steps, man. I'm gonna get ready with stuff.
That's better yesterday.
What did she do? And I can just do this.
Make sure you just use the line of code in the road. Yeah. Straight talks about that all the time. About solar off.
Yeah, he.
How we gonna do the parentheses?
Okay.
Write the code in parentheses. There, you see how you type one parentheses and then the second one automatically appeared?
Yeah. All right. We're getting there. We're getting there.
It's not bad.
All right, so different ways. Let's go through. They should have all worked. They should have all worked. So we've got mean, water $temp, and it runs it. Median runs it. All right, everything's gonna work. So we got the mean, which is the average. That's our balancing point. So if we make a histogram, figure out, we take that histogram, we put it on a pencil to try to get a balance. Wherever that point is, where we get a balanced, evenly balanced histogram, that's our average. The median is not the balance point. That's our 50% point. So that median value, we have 50% of our points above it, 50% of our points below. All right. The variance is the variance. It's variance. It's the it is the average of our squared deviance. That is the variance. It's less useful because variance is actually has units squared, where our means and medians and stuff is just the units. So because of that, we use the standard deviation, which is the square root of our variance. So now our standard deviation is actually in the same units as our mean and median. All right, both of these, variance and standard deviation, are a method of describing variation around our mean. The range, two different ways to do it. So there is the range function. The range actually gives your minimum and maximum value. That's the range. And typically when you think of range, that's what you think of. However, depending on what book you're looking at, what websites you're looking at, they might say the range is actually the spread from your minimum to maximum value. All right? I like this. I like to see what my minimum and maximum value. That seems more intuitive to range, especially if you're doing some morphological study and you're giving the average. Oftentimes you have to report the range, which is minimum to maximum. I mean, what does 15.3 even mean? If you say, oh yeah, I measured, average weight of skunks is what? What's the average weight? 600 grams?
Spotted skunk, sure, yeah.
Okay, 600 grams, and then you say, oh, it's got a range of 100. does that mean? Right? What does that mean? So I just like giving minimum and maximum. IQR. This is the interquartile range. All right, so if you report the mean, your measure of dispersion should be like standard deviation. Should be in reference to the mean. If you report the median, your measure of dispersion should be in reference to the percentiles, or to the quantiles of our data, because that's what the median is. It's the 50th percentile. It's the 50th quantile. All right? That's where interquartile range is. This interquartile range gives us the range between the 25th percentile and the 75th percentile. This does give us that range between those two values, which again is less intuitive, less important. So if we needed to get that 25th and 27th percentile, how could we do it? Anybody remember? We can use quantile function. All right. We can do 2.5 and 0.75. Help file. Yep.
What does C stand for?
Create a vector. Is concatenate. So this gives us so our interquartile range was 5.2. That is the difference between our 25th and our 75th percentile. Our quantile is actually how we found those values. So we take our quantile of our vector and the probabilities that we want, the percentiles that we want is 0.25 and 0.75. So 25th and the 75th percentile. You're going to see us use these quantiles because they'll allow us to calculate bootstrapped confidence intervals. Other stats, minimum and maximum values, min and max. And again, you're going to see with the range, those are the exact same values. The range already gives us that. Summary function does a lot of this. Summary function is going to give us the mean, it's going to give us the median, the minimum, the maximum. It's going to give us the 25th and the 75th percentiles. Other things. As we had the question, basic functions. I'm going to scroll back up to our basic functions. How about create an object and save it to memory? All right, how do we do that?
Oh, with the arrow.
The arrow.
Yeah, close.
So, object name, object. All right. How do we create a vector?
I don't want to say it.
We create a vector using C. All right. So, as an example, kind of doing all of these, we will create a vector of months. Save as. Is there a vector of month? No, it's not. That's not 2 months. No, we are going to do months. No, that's going to be too hard. First up, we will do that. We will. We'll do ages and then save it as age. So first up is we're going to create a vector of ages and save as age. So we're going to save it as age. That's our target. So that's going to be our object name. And then I do my arrow. So the less than sign and then the dash. That creates our object and we're going to save it. But we haven't created the object yet. All right, the object that we're going to create is a vector. So we're going to create our vector. And then we're going to have ages. And for ages, let's just say our ages will be 0 to 5. All right. Now there's actually a couple ways to do that. But we're going to start with the simple way. I'm going to put each item inside these parentheses. And I'm going to separate each item by a comma. So what we've done is taken these numbers, 0, 1, 2, 3, 4, 5, concatenated them into a vector. Concatenate, that's a lowercase c. And then we're going to save it as the object age. So then, when I run this, I can call the object by just referencing its name, and it will output my vector of ages, where number 1 in brackets says this is the first item. And then we have 0, 1, 2, 3, 4, and 5. If we had, let's say, 100 of these items, when we get to the end of the line, it'll start over, and that whatever is in that bracket, that is the if number in that vector. So numbers are real easy. We just separate everything by comma, works out great. All right. What about months? We're going to use three-letter abbreviations. All right. Just to save time. So we want to save the object as months. All right. We're going to create the object. All right, with the C function. And now we need it as months. Now, you might be tempted to just start typing out the three letters and separate it by comma. You will quickly get an error message. What we need to do is actually use quotation around these. Oops. So what this is telling R to do is take this text and we're going to combine it into a vector. All right. If we didn't put those quotation marks, R is going to look for Jan and think that it's first an object in its memory. And if it can't find its object, the object in its memory, then it's going to complain, I don't know what you want. I don't know what you're telling me to do. I can't find it. But if we put it in parentheses, or if we put it in quotation marks, either single or double quotes, it doesn't matter. It doesn't matter. That's why I did single. I don't need the shift key. All right? It doesn't matter. As long as we have it in quotation marks, R sees that and says, oh, the quotation marks, you're just telling me it's some sort of string. I'm not going to look for it. So anytime we work with text, it's going to have to be in quotations, single or double. Now, if you have something with a single quotation marks and you want to use quotation marks inside of that, you have to switch. Whatever's on the outside, if that's single on the outside, you have to use double on the inside. You will see that in some of our code up at the header where I have the date and I actually use system date, so it automatically generates a date for us. But that code requires quotations, and if they're not set up properly, it won't knit. So I run that, and then if I just type in months to see it, you can see that I now have a vector of. Good thing so what is C? This is R, you learn it, you get stuff here. That's why I said kind of basic functions. I think we'll probably add to this basic functions as we get to stuff that, I know I covered sometime and get to use it all the time, but if you haven't used R, it's kind of good to have. One last bit. I don't know how many of you know this. Autocomplete. Autocomplete. I'm going to calculate the mean. I want my data set was water, right? All right, it's there. Whoops. I typed in WATE and up pops water. Oops. Oh yeah. Sorry. They put this here, like right here. Whatever. So let's go back here. Actually, I'll do glyco. See how it popped up real quick. At this point, R knows found only one item. I don't have to finish typing everything out. I can hit the tab key and auto-complete it. Then I do $sign because I want the mean of, let's say, glyco. That pops up. Now I could use the arrows and kind of cycle to pick what I want, or I can type it. There's only one G. I did capital G and then tab key, and it auto-completes it. This works for functions as well. PLO has all of these functions. That's kind of less useful, but let me load the car library. Something a little bit longer. Functions. Oh, car's already loaded for me. So we're going to use Levine test, and you can see I get Levine test. That's deprecated. So I get to that. I can get to the function that I want, and then just hit tab, and it gets me right to where I need to be. Autocomplete function. And if you're ever working in the console, up. If you're ever working down here doing some quick stuff, up arrow, down arrow, cycles between the last code, the commands that were run. Very useful. All right. It also appears in the history. So if you ever get to the point where it's like, I can't remember, I deleted it, I overwrote it, go back to the history, find it. It's very easy just to go ahead and say, I'm going to copy this line. Or actually, when you highlight it, you can say to source. And it'll paste it. It'll paste right where your cursor was. Plenty of shortcuts. All right, I thought we'd get through this. Spend more time introducing R, getting you back up to speed. So now what we're going to do, I'm going to save this. So when we created it, was Untitled 1. Just go ahead and save as. All right, find a place where you're going to save it. So I got R Markdown. This one was 2.1 basic stats. All right, and R should automatically save this as an RMD. Nope, doesn't. Mine didn't. So you just make sure you add .rmd on it. And when it has that .rmd, R sees the file extension, and when it sees the RMD, it says, oh, I'm working with a Markdown document. Let's include the format. All right, so now it's ready to go. We saved it. On Monday, we'll open this up, and we'll continue working with this, adding to it. And we'll probably add some more stuff to the basic functions as we get to it, because I know we'll introduce the aggregate function to calculate summary statistics and so forth. All right, so we are good. Enjoy the weekend in 2 days.